What if a computer could solve a puzzle in seconds that would take today's machines a million years? Sounds impossible, right? But this is what quantum computers are promising. These revolutionary machines are unlocking possibilities beyond anything we thought possible. Quantum computing isn't just an upgrade. It's a complete game changer, ready to tackle problems that have stumped humanity for decades. Let's take a peek at what makes quantum computing so powerful and why it's the future of technology. Okay, let's rewind a little. To understand what makes quantum computers so special, we need to look at how the devices we use every day actually work. Traditional computers, your phone, your laptop, even the servers powering this video, process information using bits. These are tiny switches that could be either a 0 or a 1. That's it. Everything from social media to space missions boils down to combinations of those two digits. But quantum computers? They play by different rules. Instead of bits, they use qubits, short for quantum bits. And here's the wild part. Qubits can be both 0 and 1 at the same time. It's called superposition. Imagine flipping a coin and it lands, spinning in midair, being both heads and tails at once. That's a qubit. Now multiply that power across hundreds, or someday thousands, of qubits, all calculating in parallel. That's the magic of quantum computing. Massive potential packed into impossibly tiny parts. So now that we know qubits can be both 0 and 1, let's talk about what really makes quantum computing so magical. Two key concepts, superposition and entanglement, are at the heart of everything. Superposition is like doing 100 things at once. Imagine you're in a maze. A regular computer would try one path at a time. A quantum computer? It tries all paths simultaneously. That's because a qubit can exist in multiple states at once, dramatically speeding up complex problem solving. Now comes the wild part, entanglement. When two qubits are entangled, they become deeply connected. Change one, and the other reacts instantly, even if they're light years apart. Einstein called it spooky action at a distance. And yeah, it's spooky. Picture this, juggling a dozen balls, but they're tied together with invisible threads. Move one, and they all shift. That's entanglement. It allows quantum computers to process vast amounts of data in deeply interconnected ways, unlocking capabilities we're only beginning to understand. Together, superposition and entanglement give quantum computers their edge. It's not just speed, it's a whole new way of thinking. So all this quantum weirdness, superposition, entanglement, sounds cool, but why does it matter? What can it actually do? Let's start with medicine. Quantum computers could help scientists simulate molecules in ways we've never been able to, meaning faster drug discovery, personalized treatments, maybe even cures for diseases we've battled for decades. In cybersecurity, quantum computing is a double-edged sword. It could break today's strongest encryption in seconds, but it could also lead to unbreakable new forms of quantum-safe encryption. And then there's climate science. Imagine being able to simulate the entire Earth's atmosphere at once, modeling weather patterns, predicting storms, even tackling climate change. That's the promise. These aren't just improvements, they're breakthroughs. Quantum computing won't replace classical computers. It'll do the things classical ones can't. We're talking about solving problems once thought impossible. Quantum computing isn't science fiction anymore, but we're still in the early chapters of this story. The machines are real, the breakthroughs are happening, and the future? It's closer than you think. We're not there yet, not fully, but we're making progress every day. Soon, quantum computers could help solve problems we once thought were unsolvable. If you're as fascinated by the future as we are, hit that subscribe button, because at Tech Marvels Explained, we break down the innovations shaping tomorrow, one mind-blowing idea at a time. And trust us, quantum is just the beginning.